Well, good afternoon, grade 10s, and welcome to another session of Mathematical Literacy. It's always an exciting time of the day, isn't it? Because Maths Lit is fantastic. And like I've said before, compared to last year when you were in grade 9 and you did those horrible math stuff with X's and Y's and Z's and nothing kind of made sense. And now that you're in your grade 10 year, and now that you've chosen the ultimate of all subjects, mathematical literacy, I'm sure you're absolutely relieved to know that there's a mathematical subject you're beginning to understand. And that's important, because that means you're now beginning to enjoy school. And if you enjoy school, well, life only gets a lot easier from then onwards. Right, so what are we discussing today? Today our topic is interpreting data. Okay? And it falls under the huge section of statistics, right? So we are going to now say, well, rather in our previous sessions, what we did was we looked at going out and posing a question, having a problem, posing a question, and trying to solve that problem. And what we're now going to do is saying, well, once we've got all this data, once we've got all this information, how are we going to begin to interpret that information? And that's what this session is all about. So let's have a look here. So our heading today, interpreting data. And what we're hoping to cover by the end of the lesson, and what we're going to look at is this. We're going to see how we use data to draw conclusions. We're going to analyze data for a suitable representation, and we're going to be answering questions from data interpretations. Oh my goodness, now that's a lot of English. But in basic terms, what we're saying is this. We're going to look at our data, and we're going to interpret it, and by interpret, I mean we're going to look at it and analyze it. What does this mean? What does that mean? What conclusions can I draw from this or from that? And that's what the session's all about. Okay, so let's get a move on. Now, with interpreting data, what we've got here is we've got a little chart that shows us how it all starts and how it all works. So the first thing we're going to have to do is whenever we're going to look at data, we have to pose a question. What do I mean by posing a question? Well, you'll remember from our previous episodes, I said, let's pretend we had a problem. Let's pretend you're in grade 10. In fact, you don't have to pretend, you are in grade 10. But let's pretend your parents are kind of stingy with their money. And they only give you 25 Rand every month to buy airtime for your cell phone. Now, that's a huge problem for you. And if it's a problem, you're going to have to try and solve that problem. So you might want to say, you know what, in order to solve this problem, what I'm going to actually do is I'm going to go around to all my buddies, some in grade 10, I'm even going to look at some juniors like in grade 8 to 9, and then some seniors, grade 11 and 12, and I'm going to ask them how much airtime they get every single month. And hopefully they'll get more than 25 Rand. And then I can collect all this data. Once I've got this data, maybe represent my findings with a few diagrams that we'll look at later on. And then with those diagrams, come up with some conclusions by finding the mean average or the module average or even the median average, okay? Finding the range. Once I've got that information, going off to my parents and saying, "Oi, Mum, Dad, have a look here. Even grade 8s get more money than I do." Okay? Unacceptable, Mom and Dad. I need at least, how much do I need? Well, let's look at my data again. You will see that grade 10s have a mean average of like maybe 200 Rand a month for their cell phone. Hey, Mom, Dad, I think I should be getting that. Okay? So that's a huge and long and complicated way of or rather convincing your parents they've got to give you more money. But where did it start? It started with a question. And what was the question? How much airtime do you get? So it starts off with posing a question. Once I've got my question, I'm going to go around to all my friends and ask them that question. So I'm going to collect data. What grade are you in? How much airtime do you get every month? Once I've collected that data, I can do one of two things. Either I'm going to start analyzing that data, or I'm going to organize it. Now, normally, if there's a lot of data, I've got to organize it first before I begin to analyze it, okay? If I've got just a little bit of data, well, I can start analyzing it before I've even organized it. But normally the route is we pose a question, we collect the data, we organize the data, and then we begin to analyze it. And when we've analyzed it and organized it, we now begin to summarize the data. Because we don't want to go to our parents and say, I asked this kid and he said this. I asked that kid and he said that. I asked this grade 8 and he said, no. You just want to go with a summarized version. Hey, mom, dad, look at this. Grade 8s, on average, get so much pocket money. Grade 10s, okay, their mean average is so much. Just the basics summarized. Because otherwise you're going to bore your parents completely and utterly, and they're going to like fall asleep before you come to the final crunch saying, therefore I need more money for my airtime. Okay, so you don't want to bore them, you're going to summarize that information. And to summarize it and even analyze it, you can put it in forms of graphs or pie charts or diagrams. Then, okay, we've got to ask ourselves, does this graph on this data, does all this analyzing answer my question? So we're doing a complete loop, starting at the question, going around, collecting data, organizing it, analyzing it, summarizing it, then presenting it nicely, and then finally we're saying, hey, have I answered my question? All right? And that's how we're going to take our data and interpret it. Now, for the next thing, what I thought I would do is, you'll remember from our previous little session, we looked at how we display data. And I thought it would be good just to go through that again. And it's important because we cannot display or organize our data or interpret our data unless we know how it's being displayed. And so later on, what's going to happen is I'm going to give you some questions, and we're going to work through a few questions where we actually get given the data. And it could be given to us in the form of a pie chart or a bar graph or a compound graph or a double bar graph or even a stem and leaf method. But unless we know what those mean, we can't interpret a thing. So let's have a look at that, shall we? Let's have a look how data can be displayed. So displaying data. Now, the first way we can display data is by means of a stem and leaf diagram. Okay, so it's a stem and leaf diagram. Now, that very name indicates that somehow there's a stem, and you know that if you go outside in your garden and you look at a plant, you'll see a stem with a whole lot of leaves on it. Okay, and a stem and leaf diagram is just that. There's a stem with a whole lot of little things that branch off from that stem. So for example, let's have a look at the following. If I gave you the following numbers and I said we've got 21 and 33 and 25 and 30 and 22, okay? And I want to display that in the form of a stem and leaf diagram, then what am I going to do? Well, quite simply, this is what we'll do. We'll say, all right, so we've got a 0, a 1, a 2, and a 3. Now, what does that 0, 1, 2, and 3 represent? Well, the 1 represents numbers in your tens. The 2 represents 20s. The 3 represents 30s. So if I give you the number 21, instead of writing 21, what I can do is say 21. 33 can be written like this. 25, 2, and 5. 30, a 3, and a 0. 22, 2, and 2. Okay? So let's have a look at it. Let's get another color pen so we can see it even clearer. 21, 25, 22, 33, and 3 and 0 means 30. So if I've got a 3 and a 0, we've got 30. Do you understand how that works? Of course you do. And if you paid attention to our last little chapter that we did a few days ago, you'll know exactly what we're talking about. Okay? So that's the first way we can organize data, by having a stem and leaf method. Okay. Another way of organizing or displaying data is in the form of a pie chart. So let's do that over here. We're going to say the next way is by means of a pie chart. Now, you know exactly what a pie is, don't you, right? It's that thing that you dash off down to your local supermarket for, and you buy it, and it's a round little thing, and it's filled either with chicken, or it's filled with beef, or it's filled with curry, and you take this thing, and you just munch into it, and it's a whole lot of dough that's been cooked, and it's really fantastic, and inside is all the ingredients. And so as you bite on it, invariably it just oozes out and goes all over your face. Pies are fantastic, okay? Great for the waistline. No, it's not actually, sadly. But a pie chart is very similar to a pie. It is round. So a pie chart, we're going to say, well, if I had to draw one, it would be a round little circle. And that pie can be broken up into different parts. Now, if I asked you to cut a pie in half, there is no way, or cut it into sections rather, there is no way you're going to do the following. Let's have a look. Who would ever cut a pie like this? That would be hugely problematic. Why would it be problematic? Well, I would say it's going to be problematic because if you look at the guy who gets this piece, he's going to be very, very, very happy. If you look at the chap who gets this little piece over here, well, that's going to cause quite a stir. So what's the best way to cut a pie? It's to cut it from the center out. And instead of cutting pieces, we're going to cut little segments. So we're not going to cut square pieces or rectangular pieces, but little segments. So let's have a look at our pie. And the first thing we're going to do is we're going to get rid of that because that's not the way we're going to draw it, okay, or cut it. We're going to have our pie, and what we're going to do is say, well, from the center, we're going to get a knife. And now what we've got is we've got little segments of pie that we can eat. Okay. Now, some segments can be bigger than others. And we looked at that last week. Okay. The important thing about a pie chart as well is always to remember that the segments are made up of degrees. Because how many degrees are there in a circle? There are 360 degrees, not 100. Oh my goodness. Even in matric, I have students who believe there are 100 degrees in a circle. No, no. 100 is related to percentage. So there's 100%, okay? But degrees, we have 360 degrees. And that's important because we're going to look at an example of that later on. So pie chart is a picture of a round circle, and we've got little segments. So for example, I could draw a pie chart of how I spend my day. And what I could actually do is say, right, I have, in fact, let's do this quickly. Let's get rid of our little pie chart and let's draw another one. Okay, so here is a lovely pie chart. And I can say, sure, this is the amount of time that I spend sleeping. And I could actually draw it in a different color. And I could have something on the sideline that says key. Now, what's a key? A key is something we use to show what the colors represent. And I could say, right, that means the amount of time that I sleep. Okay? Then I could say, well, how much time of the day do I spend eating? Okay, now that's a bad example because obviously I'm different to what you are, and by the size of me you can see that most of my day is spent eating. But let's pretend I'm the average normal human being. We could say that I'm now spending about that amount of time in my day eating. And in my key I'm going to show that the white represents how much time I spend eating. What else do I do in my day? I go to school and I study. So what I'm going to do is say this. Okay, let's make this amount of time over here. Yeah, that's a lot of time. And that's my amount of time studying or at school. Okay, studying. Right. What is all this other time? Well, the other time could actually basically be my rest time or my personal time. The time I spend watching TV or relaxing or playing with my son or doing what my wife keeps telling me to do, okay? But it's my time. So I could give that a different color, and it's to go pink because it reminds me of my wife and she'll be telling me what to do. So pink represents spare time or doing what my wife wants me to do or playing with my son or whatever the case is, right? Do you see how a pie chart works? And the great thing with a pie chart is you can see straight away where you're spending most of your day. All right, so looking from our diagram over here, you can spend most of my day is spent studying at school or behind my books, but I'm working. Quarter of my day is spent sleeping. A little bit of my day is spent eating, and the rest of my day is spent doing whatever else needs to be done. Okay. Right, so now we've had a look at this and we've said displaying data, we can do it in the stem and leaf method, or we can display our data as a pie chart. Now, there's another method of doing it, and that would be by means of a bar graph. So let's draw a line all the way down here, and we're going to say here, oops, gone straight off the page, a bar graph. Okay, now what does bar graph look like? Well, the name says it all, doesn't it? It's a bar graph. It's made up of a whole lot of bars, okay? And so a bar graph would look something like this, where we have a set of axes, and I'm going to try and draw a straight line here, so wish me luck. So we have a straight line, gee, that's very straight, and another straight line along here, from that point all the way. Sure, I'm getting really good with these straight lines. Okay, so there's a straight line, and what we're going to actually have is a whole lot of bars. So I could have a bar up here, right? We could have another bar over there. Let's go up. Oh, my bar's not going to listen to me. Okay, let's get rid of that bar. Right, so throw that out. And we could have another bar over here. We could have another bar over here. And let's say another tiny one over there. You will notice, though, that there are gaps in between my bars. Okay. So why are there gaps? Well, for a bar chart, what we're looking at is we are looking at things that are individual units. So, for example, let's say I walk into my class and I say to my students, right, what is your favorite color? Okay, between the following four colors. And they say, well, we've got, you can choose between blue, you can choose between green, you can choose between red, and you can choose between black. Right. And those are the only four colors you have a choice of. Blue, green, red, and black. Now, if I go to a student and say, what's your favorite color? He's going to say, I like blue, or I like green, or I like red, or I like black. He's not going to say, I like bed. What on earth is bed? Sir, it's a combination between blue and red. There's no such thing. If I take blue and red, I'm going to get a totally different color. Okay? It's not going to be blade. All right? No such thing, guys. It's going to have a different color, maybe a name, maybe violet or something. I can't mix my blue and my red. In the same way, if I say to someone, how do you get to school? By bicycle, by car, or by bus? He can't say I get to school by bus. What's bus? Oh, sir, it's a combination between a bus and a car. No such thing. You're either in a car or you're in a bus. Got that? And so because they're individual things, I've got gaps between my bars to show there's no connection between those different colors or no connection between those different modes of transport. So over here, I might say, well, this is my blue, this is my green, here's my red, and here's my black. Okay? So these would be colors. What would be on the side? we would have the following word: frequency. Now, get used to this word frequency. What does frequency mean? It actually means the number of times. So if you looked at this graph here, we could say, well, there's 1, 2, 3, 4, 5. Okay? One person like blue, 3 people like green, 4 people like red, and again, only 1 person like blue. So my column on my vertical axis, okay, is called my frequency. Incidentally, let's interrupt ourselves quickly. Do you remember in the old days, those horrible days when you did mathematics in grade 8 to 9? And they used to call this set of axes our y-axis. And this axis was called my x-axis. Guys, those days are long gone. We now refer to our vertical axis and our horizontal axis. Okay? So my vertical axis normally has frequency. How many times does it occur? And my horizontal axis is going to have my different terms, or my different names, like my reds, my greens, my blues, or bicycle, bus, car, okay, mode of transport. So with our graph, the important thing to remember as well is this: got to have a title. What's this title of this graph? We are going to say this is called favorite colors. Okay, so it's favorite colors. Then I've got to have a heading referring to my vertical axis, a heading referring to my horizontal axis. Then because it's a bar graph, I have separate bars. Now, we can take bar graphs and we can make them even more complicated. And next year, when you're in grade 11, you're going to learn about a thing called a double bar graph or a compound bar graph. Okay? But we won't worry about that now. In grade 10, the one other graph we've got to worry about is something called a histogram. Okay? So what is a histogram? Well, let's have a look here. Histogram, just spelled the same as history, histo, and then gram. Okay. Now, a histogram is also a set of axes. So I've got a set of axes going down, or a vertical axis, and then a horizontal axis. Okay. The histogram must also have a title. So let's pretend we are trying to calculate the marks for a test. Okay? So we would say our title is the percentage gain for a test, or marks in a test. So let's do that. We are going to say, oops, let's get rid of that quickly, shall we? Let's write it. Marks in a test. Okay? What's going to be on my vertical axis? It's going to be the frequency, right? How many people got certain marks? And on my vertical axis, I'm going to have my marks, or my percentages. Okay. Now here's the problem, hey? If I asked you, what did you get for your maths test? Well, you could turn around and say, gee, I was quite good. I got 85%. What did you get? Oh, I got 83. What did you get? Oh, I got 5. Oh, that's sad. What did you get? Well, I got 23. Also sad, but better than 5. Now, if I asked every single person, let's say in the school, what do you get for maths? Potentially, I could have 100 different answers. Why? Because you could get someone who gets 0%, right up to someone who gets 100%. So we have the potential of having 100 bars if I were drawing a bar graph. Now that is really, really a lot of work to do. So what we do is we make life a lot easier for ourselves, and we draw it in the form of a histogram. What does that mean? It basically means we are going to take our data and we're going to group it. Okay? So what I would do then is I would say, okay, instead of saying who got 1%, 5%, we're going to say how many people got between 0 and, let's say, 30%. In other words, how many people got a level 1? How many people got between 30 and 40%? In other words, how many people got a level 2? Between 40 and 50%, or a level 3. How many people got between 50 and 60%? Okay? In fact, what we should actually do is say 50 to 59 and 60 to 69. Should we do that? Maybe that's better. 70 to 79 and then 80 and above. Okay? So all this, let's make these 39. Otherwise, what happens if we get 60? We won't know where it goes. So we're going to make 30 to 39, 40 to 49, 50 to 59. And then what we could do is we could say, all right, well, the number of people that got 0 to 30% was 4 people. 5 people got in the 30s. 6 people got in the 40s. 7 people got in the 50s. 9 people got in the 60s. 3 people got in the 70s. And 1 person got in the 80s. And what we're going to do now is this. We're going to say, right, our frequency, we've got between 0 and 30, okay, or 0 and 29. We've got from 30 to 39, from 40 to 49, from 50 to 59, all the way up. And then we're going to draw our answers. And we said we had 4 people. So let's do this. We're going to say, on our table, I'm scared I'm going to run out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. 1, 2, 3, 4, and this is 5. How many people got between 0 and 30? 4 people. So we say 1, 2, 3, 4, and we're going to draw a column down there. How many people got in the 30s? We said 5. So let's do 5 up here. How many people got in the 40s? 6. So we're going to go all the way up to 6 over there. Okay? So all the way up to 6. And so on. And that's how we are actually going to draw our graph. Now you will notice from the graph, there is no space in between those columns. And the reason there is no space is, look at this. 0 to 30, 30 to 39, 40 to 49, 50 to 59. There's a continuous set of data, right? It's continuous and they're all referring to the same thing, marks. Whereas in our bar chart, if you remember, we had red, we had green, we had yellow, okay? Separate little things. Here we're saying we've got marks that range from 0 to 30 and we're grouping the data. So as soon as I have group data, and they're all the same thing, like all marks, it might be all kilograms. How much do you weigh? And all these people tell me how much they weigh. And I put them in certain categories. Then those bars are also going to touch each other because the units will all be kilograms. So we've done a lot of work, hey? And it's mainly summarizing. But you know what? This is so important because you can't go on until you understand this. Now that we've done that, I think it's time for us to have a quick break, and then we'll come back and we'll tackle some of these questions. Well, welcome back. I trust you've had a good break. And remember, before the break, we were looking at how we display data and how we interpret data and how we represent the data. And now what we're going to do is we're going to look at a few examples. And hopefully all this information we've learned so far, we're going to take it and we're going to put it in context and we're going to be able to apply it. So without any further ado, let's look at a question. The following stem and leaf diagram gives the ages of males and females that attended a seminar on work in the future. Okay, so let's have a look at this quickly. We've got males and we've got females. So they're our males that have attended, and we'll use a nice pink color to represent our females. Okay. Now, this is how old these people are. Do you remember with the stem and leaf diagram, we had a number on the left-hand side, and then on the right-hand side, we wrote down the units column. Okay, so let's have a look here. This 1 represents everything in my tens. So 1 and 9 represents 19. 2 and 2, 22. A 2 and an 8 represents 28. What about the 3 and the 0? It represents 30. Or the 3 and the 6 represents 36 years old. Look at this. What is the 6 and the 0? The 6 and the 0 represents 60. Now, because we're dealing with males and females, we want to see the comparison between the two. What we've done, because on the right-hand side we're showing the males, on the left-hand side now we're showing the females. So let's have a look here. So in the same way, where this number over here represented 32, this number here also represents 32, not 23. Don't get mixed up with that, okay? The number in that middle column is still my tens. So it's 32, or it's 32. Got it? Okay? So looking at this, you can see that this number over here is 54. This number over here is 19, which is 19. Or how about this? 42. You get the idea? You realize how to read that? So my males is 42, my females 42. Okay, right, so let's now look at our question. Our question is this. Calculate the median age of the males and the median age of the females attending this seminar. Okay, so that's what we're going to do. Now, do you remember how we calculate median and how we calculate mode and how we calculate mean? Of course you do. Why do you? Because you would have watched last episode or the episode before when we focused on mean, median, and mode. But just to recap, our median is going to be the middle number. Remember? So we're going to put all our data in order, and then we're going to find that middlemost number. Now, the great thing about a stem and leaf method, it kind of makes it easier for us to put it in order. Let me show you what I mean. Let's look at the females. With the females, we're going to start here at the bottom and work our way up because we're starting with our smallest number, which is 19. So if I were to put it in order, I've got a 19, used it. Then I've got 20. 20 what? I've got 22, 24, 25, another 25, a 27, a 28, and a 29. I've got 31, 32, 33, and oh my goodness, I could be here forever writing that out. But the nice thing about this question is they kind of put it in order for us already. Let me show you what I mean. What they've actually done is you can see I've got 19, then 22, 24, 25. I got 25, 27, 28, 29. So instead of putting my data out this way horizontally and crossing one off on each end to get to the middle, my data is spread out this way, and I'm going to start crossing off to get to the middle one. So how are we going to do it? Let's have a look. My highest number here is what? It is 54. So let's cross off 54 and cross off my lowest, which is 19. My next highest is 52. And my next lowest is 22. So we're going to cross off one high, one low. Now, here's my next highest, lowest. High, low, high, low, high, low, high, low, high. Now look here, 31. Then 36, 32, 34, 32, and voila, we found our middle number. So for our females, my median is 32. Right now, we're going to find the median for the males. Now, there are a lot of numbers for the males, okay? So let's start and get going with this. So my highest is 60, my lowest is 19, and there it goes. My next highest is 53. Let's cross that off, and my next low is still 19. Then we're going to cross 1, 2, 3, 4, 5 of those off, okay? Because those are my highest, and my next lowest is going to be 21, 22. So let's knock off 5. 1, 2, 3, 4, 5. Then 51 and 50. Then 23, 23. Then 49, 48. Then 24, 24. Okay, let's knock off 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 that side. 1 to this side, 1 to that side. What's my next highest number? It's going to be 37. What's my next lowest? It's 27. Let's knock off another 2 here, another 2 there. Now, what's my next highest number? 34. My next lowest number is 30. We're starting to come into the middle here. So let's go. So I've got 34, 34, and a 30, 31. A 33, 33, and a 31, 32. Now watch out carefully. One that side, one that side. What is my median this side? It is also 32. Okay. So what I've done here is quite complicated, hey? And it can cause a bit of confusion, believe it or not, but people make mistakes when they do this. So what I highly suggest is this, that if you don't understand how we've crossed off here and crossed off there, just write the numbers out, okay? So you could write 19, 22, 24, 25, like we did initially when we started this, okay? So 19, then 22, 24, 25, etc. Write them all out in one long line and cut off until you get to the middle. Okay, so if you didn't understand what I did here, it's not a huge train smash. Do it the good old-fashioned way. Okay, now, calculate the median age of males and the median age of females attending the seminar, and that's what we've done. Next question, was there a large difference between the median ages? Well, no, not at all. In fact, there was no difference. It was exactly the same. Median for females was 32. Median for males was 32. The difference, nothing. Okay, let's go on to our next question. What else is significant about the data sample? What do you notice about this that is quite interesting? Let's have a look. Get rid of all this. Well, the first thing you'll notice is this, that there are a lot of young people attending this seminar. Very few people in their 60s. In fact, only one. Few people in their 50s. A lot of people in their 20s and 30s. Do you see that? Look at all these people here. And they're all going off to the seminar. The other thing I noticed was there were more males at the seminar than females. Wait, does that mean males work harder than females? I don't know, and I'm not in a position to answer that for the sake of my life and my sanity, because remember, I'm married and my wife may be watching. So all we can conclude is this: a lot of people watch in their 20s and 30s and or went to the seminar, and in this instance, there were a lot more males than females. Okay, now, next thing. Let's go on. What is the modal age for the males in the sample? Sure. What's modal mean? Do you remember? It means the mode. In other words, what age was the most popular amongst the males that attended this? Well, let's have a look here. Now, you know that 60 means 60. We got 50, 51. We got a lot of 52s. In fact, there are 3 52s there. I'm going to underline. Here I've got one of each except 2 8s. I got 2. I got 3 2s here, which means I've got 3 people 52, 3 people 32. Okay, let's look at our 20s. Hold on. We've got 4 people in their 24, and we got 4 people 25. So what's the modal age? Well, it's going to be 24 and 25. Hold on. Are we allowed to have 2 modes? Of course you are. You could even have a situation where there is no mode. Let's say I gave you 5 numbers, and they were number 1, 2, 3, 4, 5, and I said, what's the mode? Well, there is no mode, because there's only one of each. Let's say I gave you 10 numbers, and it was 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. What's the mode? Well, there is no mode, because they're all 2 numbers of each. Let's say I gave you 1, 1, 2, 2, 3, 4, 5. What's the mode? The mode would be 1 because there are 2 of them, and 2 because there are 2 of them. Okay? So my mode would be 1 and 2. In the same way here, my modal age is 24 and 25. Got it? Of course you have. Next one. Can you give a reason for this modal age? Why did so many people who were 24 and 25 attend the seminar? Well, let's look at the name of the seminar. What was the name? It was Work in the Future. Okay? So, you're not going to have people in their 60s and 70s saying, let's think about our future here and what work we intend to do one day. Not at all. By then, it's far too late. Okay? So it's the young guys, 24, 25, and the young females in their 20s and in their 30s who are saying, we're still young. We could make a career change. In fact, let's look at how we should be working in the future. And let's make a difference in our workplace and how we present things and how we deal with people, how we earn extra money. Okay? Because it's important. Why? Because I'm still young. You will notice from this information here, only one person who was 60 years old thought they could change their working conditions for the future. Okay, poor person, they probably intend to work till about 80. Well, then they still got 20 years to go, and of course, by then, concentrate on how you're going to work in the future. No one in their 70s attended, and nobody in their 80s attended, and no one in their 90s, and no one in their 100s, okay? Way too late by then. Right, next question. So, explain why there's a large drop in the number of participants in the higher age categories. Well, I don't need to do that again. We've just discussed it. Because when they're older, they're not worrying about work in the future. Next one. Now, some conclusions. Now remember, once we've got all our data, we've got to draw conclusions from that data. Let's read what this has to say. It is important to be able to draw conclusions about information given in data sets. Answering the questions that ask you to give reasons can be difficult. Always try to relate the answer to the theme of the question. For example, in answering the question on the reason for the model age of the male group, we could have said the following: because these ages were bored and had nothing better to do, or because these ages are often looking to further their careers as they have a longer future in the working world. Now, answer B is clearly better related to the theme of the question and gives a well-reasoned answer to the question. Okay? So we've taken our information, and when we draw a conclusion, the conclusion must be related to the entire topic. Imagine if I said, why did so many people in their 20s and 30s go off to the seminar? And we answered, because they were bored. How on earth can we come to that conclusion? 20s and 30-year-olds are never bored, right? Got so much fun things to do, like raising kids and all weird and wonderful things like that. They are not bored. But what we have said was this: because the seminar is based on work in the future, it doesn't have the same effect on the older generation. Okay? So when you answer a question, make sure your answer, make sure the conclusion you come to has something to do with the whole question. Got it? Right, let's move on. Analyzing data for a suitable representation. When we are given data to sort, we need to ask ourselves how we want to represent the data in order to analyze it. Now, do you remember just before the last ad break, we said there were a number of ways of representing data. We could use a stem and leaf method, we could use a pie chart, we could use a bar graph, or we could use a histogram. So if suddenly now you had to decide which one you wanted to use, wait, how do we make that decision? Now, here's something I want to bring to your attention. In a test and in an exam, your teacher should not say to you, you decide how you want to represent this. You decide if you want to use a bar chart or a histogram or a pie chart or a stem and leaf method. your teacher or the examiner should guide you through that and say, you know what, take this information and represent it as a pie chart, or take this information and represent it in a bar chart. They should never make you make that decision. However, as an assignment, and this is something I love doing with my classes, as an assignment, I could say, you pose a question, you've got a problem, pose a question, put it all together, draw up a survey sheet, get that information, and then you represent it in the best way you think is the best to feed it back to me. Okay? Now that I can do, but I do that as a worksheet or assignment. I don't think it's fair for your teacher to say in a test, draw it any way you want. Okay? But how would we decide? Well, when we are given data to sort, we need to ask ourselves how we want to represent the data in order to analyze it. So, a group of school children go to the zoo and are asked which was their favorite animal at the zoo. Oh, do you see the spelling mistake? So do I. Tut tut, that's bad, hey? How do you spell there? It's their chocolate. T-H-E-I-R. Okay, but we can all make mistakes, so we can forgive the person who wrote this. Okay, so a group of children go to the zoo and are asked which was their favorite animal at the zoo. The following results were given. Grade 1 said, 4 of them said, we like the lions. 18 of the little children said, we love monkeys. 2 said, oh, we just loved the tigers. All those stripes and things were fantastic. 10 people loved the birds. And 8 guys in grade 1 loved the elephants. As we go down the grades, so we see the figures begin to change. In grade 2, 6 liked the lions. In grade 3, 10 liked lions, 12 liked lions, and 16 liked lions when they're in grade 5. Okay? And look here at the birds. 10 people like birds in grade 1. Only 1 person prefers the birds in grade 5. Okay? 14 love the tigers, such majestic animals. In grade 1, they don't know that they're majestic, they just like the stripes. And stripes remind them of work, okay, like maths. 1 stripe plus 1 stripe is 2 stripes. So only 2 of them like tigers because they don't like maths. So 2 of them like tigers, but in grade 5, 14 of them like tigers, for whatever reason. Okay. Now, we could do various representations of data for this chart depending on what we want to know. Let's have a look at that. We could total all the animals and create a bar graph to see which was the most popular animal over all the grades. So what I could actually do is I could draw a bar graph like this. And I could say, right, let's draw a chart. Here is our chart. And what we're going to say is this, that I have the lions, I have the monkeys, and I have the birds and whatever else animals. And I could here say the frequency, okay, or the number of students that like that. And we could add it all up. And we could say, right, lions, we had 4 and 6 is 10 and 20 and 32 and 48. So we could say, sure, 48 people like the lions. How many people like the monkeys? Well, let's have a look. We've got 18 and 14 is quite a lot. That's, what's that, 32, and another 14, and another 12, and another 10. Sure, that makes so much. So we could draw another bar graph showing how many people like the monkeys. Okay? Notice the bars are not touching. Why? Because a lion and a monkey are 2 totally different animals. We can't have a line key. There's no such thing as a line key. Right. So lion, monkey, birds. So that's one way we could represent the data. How else could we do it? We could do a bar chart for each grade and compare which grade liked which animal the most. So there's another thing we could do. We could say, well, let's draw another bar chart. And we could draw it down here. Okay. And we could have a heading that said the number of lions like best. Okay? And here we could say grade 1 grade 2, grade 3, grade 4, grade 5. And on our horizontal or vertical axis, we've got the frequency. And we could then draw it and say, okay, well, for lions, 4 in grade 1, 6 in grade 2. So we could say, right, 4 loved it in grade 1, 6 loved them in grade 2. In grade 3, we had 10, 12, 16. So we could say 10, 12, and right up to 16. And just by looking at that, you could say, whoa, grade 5 liked the lions the best. And we could do that for every single animal. We could draw a graph like that for lions, for the monkeys, for the tigers, for the, what other animal? Birds. Okay, so we could have a whole lot of graphs like that. How else could we do it? Well, let's have a look at point 3 here. We could do a pie chart to see the percentage of children that attended in each grade. Okay, so another thing we could do then is actually draw a lovely pie chart, a circle, and say so many people came from grade 1 to the zoo, so many people from grade 2, so many from grade 3, so many from grade 4, and so many children from grade 5 came along to our zoo. Can you see how we can take data and represent it in so many ways? It's exciting stuff. In fact, it's so exciting, I got to dash off and grab a glass of water. So we'll chat soon, straight after the break. Welcome back, folk. Just before the ad break, remember what we were doing? We were looking at different ways of representing data. And we came to a conclusion that we could take some data and we could represent it in the form of a pie chart or a bar chart. We could even take it and put it in the form of a stem and leaf method or even a histogram. So how do we know which is best? Let's have a look here. Analyzing data for a suitable representation, we've got to draw the following conclusion. Depending on the type of questions we want to answer about the data, will determine what type of chart we would like to draw. Okay? But remember what I said? Normally your teacher in a test or an exam will say, draw a pie chart to represent this, or draw a bar chart, or draw a histogram. Now, let's go on. And what we're now going to do is we're going to look at answering questions from data interpretations. Let's have a look at our first question. So, a store sold packets of chips and collected the following data. Let's have a look at that. So what's actually happened now is someone owns a shop. And in the shop, they're selling different packets of chips. Now, it could be a shop, it could even be your tuck shop at school. And they're saying, we got tomato sauce chips, salt and vinegar chips, we've got fruit and chutney chips, and we've got the good old plain chips. Those are the 4 flavors we're selling, and let's see how well they sell. And so what they do is someone stands behind and says, there's a tomato sauce salt. Cool. He's buying a plain chips. He's buying a salt and vinegar. He's buying a fruit and chutney. And so they add it up over a period of time. And these are the results they get. Let's have a look at it. Tomato sauce, they realize that they've sold just lower than 250, maybe 245. Let's pretend that's 245 packets of chips. Okay. The salt and vinegar, they've sold round about 120 odd. Fruit and chutney, 400. How many plain chips are sold? Can you decide that? Round about 320. It's not quite halfway because halfway would be 25. So it's not quite halfway. So I'm going to say around about 320 packets of plain chips. Okay. Do you see how they've represented it? Do you see they've represented it as separate bars? Why? Because you can't get tomato and vinegar. No such thing. It's tomato sauce chips, salt and vinegar chips, fruit chutney chips, or plain chips. You never go into a shop and open up a tomato sauce packet of chips and get 1 tomato sauce, 1 salt and vinegar, 1 fruit and chutney, and 1 plain chip. It just doesn't work like that. Okay? They individually packed. Fruit and chutney chips are separate to tomato chips. Okay. Now that we've analyzed this, let's look at the type of questions they're going to ask us, forcing us to interpret the graph. And that's just one thing I want to say to you now. in a test or in an exam, you could be asked to draw a bar chart, or they could give you a bar chart and ask you information about it. So you could be given information, now draw the chart, or we could give you a chart and ask you about the information. And in this case, you're given the chart, so they're going to ask us something about the information. Let's have a look. First question. Which flavor was most popular? Well, looking at that, guys, this is not even difficult. Obviously, it's our fruit and chutney. The next question, which flavor was least popular? Again, guys, this is such an insult to our intelligence. You can see it straight away. Salt and vinegar was the least. Now, how many units of the plain flavor were sold? We've done that, haven't we? 320. Next question. How many units were sold altogether? Now what are we going to do? We're going to have to add all these up, aren't we? So we're going to take our calculator and we're going to say, right, of the plain, we had 320. Fruit and chutney, we've got 400. Salt and vinegar, we got 120. And finally, our tomato sauce, we got 245. So how many chips were sold that day? Equals 1,085. So we had 1,085 packets of chips were sold. Next question. What was the difference in units sold between the most popular and the least popular? Well, this is also easy, isn't it? Because we know our most popular were 400. So let's do that. We're going to say, right, we've got 400 packets of chips, which was most popular. We are going to subtract the least popular, which was salt and vinegar, of 120. What's my difference? 280. So we've got 280 was the difference. Next question. If the store owner makes 50 cents profit on a packet of chips, how much did he make in profit from the sales given in the set of data? So we know our store guy is making 50 cents for every packet of chips that he sells. How many packets of chips did he sell? Don't you remember we added them up? What did we get? We wrote our answer over here, 1,085. So we're going to say, right, 1,085 chips, packet of chips were sold, and he made 50 cents on each one. So we're going to say, cool, we got 1,085, multiplying it by 0.5. Why 0.5? Because it's 50 cents. And in rands, it's R0,5. Got it. Equals, and my answer is going to be 542 Rand 50 cents. So it's 542 Rand 50 cents. So, it's not bad, eh? Nice way to make money. You should try it. Go out, buy some chips and sell it to your buddies and make 50 cents profit. Next one. Based on this data, what would you recommend to the store owner when he restocks the store with chips? So if you were the guy working in the shop and you said to him, right, we need more chips. But I tell you what, pal, don't go and buy salt and vinegar. We're not selling many of them. We only sold 120. And he said, well, which one should we sell? Which one should we buy more of and stock more of? You know what? If I were you, I'd buy lots of fruit and chutney. Why? Because we're selling so many of them. Just look at this on the graph. And he's going to say, geez, that's impressive. What else should we buy? Well, I'd also buy some plain chips because we sold 320 of them. I would buy a few less tomato sauce. And you know what? Salt and vinegar, I wouldn't buy very many because we're only selling 120. Can you see how this is being used to take our data, interpret it, and use it? Okay? Because imagine if we did all this research and we came up to a conclusion and the shop owner came and said, right, I'm going to buy chips. What should I buy? And you say, buy everything. Okay? Absolutely everything. We are just selling chips like you can't believe. We sold 1,085 packets just yesterday alone. You just go buy chips. Well, that's not really true, hey? Okay? Why? Because salt and vinegar didn't sell as well as our fruit and chutney. So we had to take our data and interpret it correctly. Let's have a look at our next question. So, given the following pie chart for car sales in the month of May, answer the questions that follow. So here now we've got a pie chart. You can see it's a pie chart because it's round. And so that symbolizes a pie chart. Look at our key. This thing over here is our key. Our blue color shows us how many Toyota cars were sold. And there are quite a few of them, aren't there? The red shows us the Mitsubishi. The green, the Ford, how many Fords were sold. There it is there. Our VW is purple, and there's all our purple coloring there. So you can see what that's symbolizing. And from that, without even looking at some questions, we can say the following. The car that's sold the most, or the most popular car sold in the month of May was our Toyota. Okay? Our least popular was our Ford. Okay. Now, for the sake of our sponsors, let me tell you, this is not all true, all right? But we're just using this as an example. So we don't want to be sued by Ford or VW or Mitsubishi, okay? That's not true. We just made this up. Cool. Let's move on. Now, let's answer the questions which follow. Which brand sold the most units? Well, in this example, we can see it was Toyota. Why? Well, gee, look at all that blue color there. Next question. Which two brands sold similar amounts during the month? Okay, well, let's have a look at it. Look at this red and look at this purple. They're pretty close, aren't they? Okay, if I took that purple and I shifted it down on the red, okay, I'm going to say, well, that's almost the same as the amount of red that was sold. So which two are similar? I would say the red and the purple, the red representing the Mitsubishi and the purple representing VW. Next one. Estimate the angle for the sector of the Toyota brand. And that is important, okay? We have got to say how big, let's get rid of all this, and I'm going to use a different color altogether. Let's go with our green. How big is this angle from there all the way down to there? So from that point to that point here. How big is that angle? Sure. Now, guys, you know that a whole circle is 360 degrees. What's half a circle? It's going to be half of 360, which is 180 degrees. What's a quarter circle? Well, it's going to be quarter of 360, or half of 180, which is going to be 90 degrees. So if I were to draw this in, I would say over here, let's draw this line over here, that is going to be 90 degrees. This over here is 180 degrees. Now, where's this line over here? I would say this line is halfway between 90 and 180. What's halfway between 90 and 180? It's going to be round about, what should we say, 120 degrees? Okay? Or 130 degrees maybe? So you could say, look, that's 120 or 130 degrees. And I would give you the marks for that, because you are showing, hey, I know it's between 90 and 180 degrees there. Okay? Or you could even say it's 125 degrees. I know it's close to that 120, 130 mark. And the question did say estimate, and that's what you're actually doing. If it said to you exactly what is the angle, we'd have to give an accurate answer. But from this information, we wouldn't be able to do that. So we've only been able to estimate our answer. Right. Now it says express the VW sales as a percentage of the total sales. Let's have a look at this now. So VW, we want to represent it as a percentage of the total sales. What do you think this is? I think this is 90 degrees over here. So all this represents 90 degrees. 90 degrees of the total circle. What is the total circle? The total circle is 360 degrees. Now, what is 90 over 360 times 100? Because I want it as a percentage. So we're going to say times 100. Let's take out our calculator and let's do this. We've got 90 over 360, okay, multiplied by 100. And that's going to give me 25%. So we have 25%. Okay. I want to do that on my calculator again because some of us might be using a calculator that doesn't have the fraction button. So what does 90 over 360 mean? Let me show you on the calculator. 90 over 360 could be done as 90 divided by 360. And then we times by 100, and look, we're going to get the exact same answer, 25. So my answer then is 25%. Okay, I think that's all the answers there. Right, done it. Next one. So from this graph, we have another question. If there were 25,000 units sold altogether, calculate the number of Toyotas sold in that month. Now, do you remember the Toyota? We said that this angle over here was round about 120, 130. I'll tell you what, let's make it 125 degrees. So if it's 125 degrees of the full amount, which was 360 degrees, and we multiplied that by the 25,000 cars, then we will know how many Toyotas were sold. So we are going to say, okay, so we've got 125 divided by 360, multiply that by 25,000 cars sold, okay, equals, and our answer is 8,680,555. Guys, I'm not going to have a comma 555 because hopefully when I go and buy a car, no salesman sells me comma 555 of a car. Then I've got huge problems. So I'm going to round it off to the nearest whole number and say my answer is going to be 8,681. So 8,681 cars were sold. If the number of Toyotas doubled in sales, how would that affect the number of cars sold in the other categories? Well, it wouldn't affect them, would it? Because we've still sold so many VWs, so many Mitsubishis, so many Fords. But my amount of Toyotas sold has doubled. Now, how would that affect my pie chart? Well, that's going to affect it greatly, isn't it? Because now, instead of selling 25,000 cars, I've sold more than 25,000 because my sales in Toyota doubled. So of the 25,000, I'm going to add 8,681 and say, you know what, I've actually sold 33,681 cars. Now, instead of making my pie chart out of 25,000 cars, it's now out of 33,681. So my section for my Toyota is going to increase. My section for VW is going to decrease a bit. For Ford is going to decrease. For Mitsubishi is going to decrease a little bit. All right? So we're just interpreting that data as we've posed different possibilities. Okay, so how would it affect the number of cars sold? We're going to have sold an extra 8,000 cars. How does it affect the pie chart? Well, for the pie chart, the Toyota section is going to get bigger and the others are going to get a little bit smaller. All right. Guys, we've covered a lot of work today, hey? We really have, and I'm really proud of you for staying tuned in for so long. But the time has come for us to end this. I trust you've learned a lot. I know I have. And I've had great fun presenting it. And hopefully you've had great fun watching it. Okay. Remember, stay tuned. We've got a number of series still to go on this whole wonderful section of mathematical literacy for grade 10. We'll be meeting soon, I'm sure, in the near future. Until then, cheers. And remember, enjoy school. Cheers.